Okay, so yesterday we learned all these rules. If we have something with multiplication in a log, we can separate them with add. And if we have a division, we can separate them with subtraction. And if we have an exponent, we can become a multiplier, right? Remember those rules? Okay, so what I need you to do with this separation is glue it back together. Okay, so if they were separated with adding, that means they would have been multiplied with each other, glued back together, right? Okay, so this is a log equation. So what I want you to do now is change it to an exponential equation. So what's your base? Exponent, result. Show me that. Base to an exponent equals a result. Move it around. Okay, does that make sense what I did? Now it's just all algebra. So 16 equals 10x minus x squared. What do you do algebraically if you see all these parts? 0? Yep. I don't like having negative x squared, so I'm going to go that way. Multiplies to 16. Okay, remember that in a log expression or a log equation, the result has to be, what's the rule? In a log, the result has to be positive, right? No matter what. Okay, because if you take a base to any exponent, it will be positive because we're not dealing with negative bases. Okay, so let's just check. If you were to plug in 8 there, 10 minus 8, that's good. That's positive. 2, 10 minus 2, that's good. That's fine. We can leave it. Otherwise, sometimes you will have to cross those out if they don't work. Okay, on to the next type. This is an exponential, right? Does this make sense? It looks exponentially. So now what I'm going to do is log it. So I'm going to log both sides. All I did was put a log in front. Okay, now the rules. You ready for the rules? This is an exponent of a log, so what could I do with it? I could change it to a multiplier. This is an exponent, so what can I do with it? Again, change it to a multiplier. Okay, on this side, you're going to have to distribute that multiplication. This is going to move to that side because it doesn't have an x in it. I'm trying to get x stuff alone, right? And the last maneuver, I'm trying to get x all alone, so I'm going to have to divide by 3 log 7. Divide by that 3 and that log 7. Okay, so here comes the big part. Typing into your calculator. Jackson, we're still got that backwards calculator? Yeah, you're going to give up on that today. That's done today. Okay. I'm going to be doing brackets divide by, right? Because I want to keep that. Some of you might have a brackety calculator. So for instance, when I push my log button, I don't have a bracket. So I could just do something like that, like the log of 5. I can just straight type that. Some of you might have a calculator. Do you know who you are? If you have a calculator that as soon as you type log, it opens a bracket? Does anybody have that style of calculator? As soon as you push log, did you get a bracket? Because if you do have a brackety calculator, you're going to be putting in lots of brackets. Okay. Yours is normal. You have a brackety one? So you're going to be like a lot of brackets going on. Okay. So give me a bracket. 9 log 5. So Griff, right there, you would have had a bracket just around the 5 yet. Minus log 7 bracket. So Griff, your calculator would have had a bracket. Right? 2 after the 7 technically, right? Okay. Everyone's good? Divide by 3 log 7. Jackson, did you do it? With a normal calculator? Okay, you didn't even try your backwards one? No. Okay. I had one person that did figure it out, but I had 15 other people that gave up. How'd it go? Do we match?
So you don't have to put brackets on the bottom?
No, because it's just one thing. Yeah, but this was 2, right? Okay, let's go to the one below it. Okay, so this is exponential. So what am I going to do? I'm going to log both sides. Okay, so I'm logging both sides. All right, you ready? There's actually 2 items in there connected with multiplication. So I'm going to have to split them with an add. So log 5, and instead of times, I'm splitting them. And then, you know what else I'm going to do? I'm going to move the exponent into a multiplier on the 7 part. Do you see that setup? Split the multiply with add. I moved the exponent to a coefficient multiplier. Okay? That exponent has nothing to do with the 5. Right? You see it? That exponent is not on the 5. Equals, move the exponent in front multiplying. Okay, next step is to distribute that. Okay, that's okay. when you look at this, here's what you're going to think. Anything that contains an x will need to be grouped on one half of the equation, and anything that's no x is on the other half. So what does that mean? I'm going to move that to collect xy items onto one side. So there's no x in that, no x in that. Okay, so that's algebra. You're going to collect x stuff, non-x stuff. Separate that. Okay, on the x side, what I'm going to do is I'm going to GCF So GCF the x out. And now the last step is to divide. Right? I need to divide that. Divide. Okay, so this is your calculator stuff now. So we're all going to practice because it's hard. So remember on this one though, when you divide, you need brackets, divide by, and then this one you have to do brackets. Okay? Let's see if we can all do that type. And then remember this kind of stuff, you got to do 3 decimal answers. Or you could just do a y1, y2, intersect. That's this one. Yay, nay? I feel like this is one of the outcomes that you just feel like jumping up and down cheering when you get the answer, because it's so rewarding because you put in so much typing and so much work. Okay, you can technically check your answers, right? You can always plug x into that to see if you did it right. Okay, and I'm going to do this one below it. Okay, so this is exponentially looking. Okay, so what am I going to do? I'm going to log both sides. But I'm actually not going to log both sides. I'm going to try something else. Natural. I'm going to natural log both sides. Okay? And the reason is because there's an e involved. So instead of logging both sides, I'm going to natural log both sides. Okay, ready? Exponent becomes a multiplier. Exponent becomes a multiplier. Does anybody know the number for what is the ln of e? No, that's e. E is 2.7, but what is, if I do an ln of e, without my calculator, I should know this. Okay, what is the base of this? When you have an ln, what is it using as a base? It's using a e, and then the result was e. So it's a 1. So this is 1. So here, the ln of e is 1. And that's why, because it uses a base of e and it's telling me the result is e. So my exponent is 1. Okay, so then it's gone. So that means I would move that number and then I would divide by 5. Okay, would it have been wrong if I logged both sides? No. But you would have had 5x log e plus 7 log e equals 5 log 7. You would have just had to do more work because log e doesn't just cancel. So you would have got there the same way. It's just that doing the ln saves you some work because you get to cancel it out.
So whenever there's a basis, you
Try to use the ln, yeah. Okay, remind me what I had a blank page on, like an answer key or something was blank on the back. Ends. Okay, so this was kind of a big idea. So if you had a log equation, what did we do? We glued it back together with the rules. So if we had a log equation, we glued it back together with the rules, and then we changed to exponential. So that's what we did. Log equations, we glued it back with the rules, and then we changed it to exponential. So then, what did we do if we had an exponential equation? We logged both sides, and then we separated with the rules. Do those patterns seem inversely of each other? You know what inverse means, right? Switching x, y. Okay, we're also switching the strategies of solving the equations, right? Glued, exponential, logged, separated.